start our last unit for um, this semester. And this unit will be all about right triangles. Today we're going to talk about a skill that you have to have in order to be able to work with right triangles, and that is simplifying square roots. So just as a reminder, a square root of a number is a number that when multiplied by itself gives the original number. So the square roots of 16 are positive 4 and negative 4, because 4 times 4 is 16, and negative 4 times negative 4 is 16. By the way, let's say we wanted to find the square root of 17. And you're like, well, how am I supposed to do that? Well, the square root of 17 is written the square root of 17. You could give a decimal approximation for this, but the value of that is a non-terminating, non-repeating decimal, which means you could write for the rest of your life and never get to the end of it. And the importance of that is that it's the square root of 17 because the square root of 17 times the square root of 17 is 17. That's the definition of a square root. And you're like, is that a big deal? Oh gosh, yes, it's a big deal. In fact, everything that we do today is predicated on that idea, that the square root of a number multiplied by itself gives you the number. So if we only want the positive square root, which is true for all the problems that we're going to be doing in this class this year, we write the square root sign. This is the principal square root, although we usually just say the square root. This is also called the radical sign. And you may be wondering, why the heck is it called radical? Normally when you think of someone who is a radical, they have weird ideas, right? They're strange or whatever. Well, the idea of a square root, when it was first being kind of discovered, was a weird idea. People thought that there were no numbers like this. And people who thought that there were considered weirdos, okay? At least within the mathematics community. And so that's why it's called the radical sign. So one of the important things that you need to know is something about the principal square root. And when it's a whole number, that original number is called a perfect square. You should have a lot of these already memorized, and since you're doing everything in this unit without a calculator, you should extend whatever it is that you do know. So however far you know these, push it further. I would say, at the very least, to here.
Oh.
I would say that's at a minimum. It comes up often enough to where it's worthwhile. And now I get to tell you one of my secrets. It's not that big a secret, but when I was in elementary school, back while the earth was still cooling, I didn't memorize my multiplication tables. I just didn't. I figured I can add fast enough to where I can figure out what that is. And so I did for a very long time. In fact, I was in Algebra 2, and I was doing things like if I had to multiply 6 times 8, it was like 6 and 6 is 12, that's 2. 12 and 12 is 24, that's 4. 24 and 24 is 48, that's all 8 of them. That's how I was multiplying. And a voice in the back of my head said, hey, stupid, you should just memorize this. And I did, okay? Whether or not something is worth memorizing is in the how much do you use it. With these, you're going to use them often enough to where it's worth memorizing them. And again, that's from a guy who delayed memorizing the multiplication tables until he was 14, 15 years old. Okay. Now, let's talk about simplifying square roots. There are two different methods for simplifying square roots. One of them requires more thinking, but is always faster. The other one is more mechanical, but almost always takes longer. I will leave it entirely up to you as to which one you do. I will say, historically at least, way more people choose the more mechanical one because they don't want to have to spend as much time thinking. Okay? But it's up to you. So the two methods are perfect prime factorization and perfect square factorization. So let's turn it over and look at the two different ways to do this. For example, if we want to simplify the square root of 700, in order to do perfect square factorization, what you have to think of is the largest perfect square that will divide evenly into that number. This is part of why knowing the perfect squares is helpful. 700, well, this is actually a pretty easy one. Clearly 100 divides into that evenly, and 100 is a perfect square. So what we can do is say the square root of 700 is equal to the square root of 100 times the square root of 7, so that's 10 square roots of 7. And in fact, if you don't want to write this middle part, you can go straight from the square root of 700 to 10 square roots of 7, and I'm not going to be on your case about you got to show your work. Okay? I'm fine with that if you can do that in your head. Fact is, it would make me really happy if you could do that in your head. Now, here's how prime factorization works. What you do is you take the number and you divide it up into prime numbers. I've done it this way for years, where I divide going down. If you prefer, and this is what I show my on-level geometry students, if you're like, oh, I kind of prefer it if I do factor trees. You've done those a lot, right? Yes? You got at least one head shake. And then you go, okay, divide that up into 10 and 10, and then divide this up into 2 and 5 and 2 and 5. The only reason I don't like this, it actually is more writing than this is, and students tend to lose ones because they're not particularly neat. In either case, what happens is we end up with two factors that are 2's and two factors that are 5. And what we're doing is saying the square root of 700 is the square root of 2 times the square root of 2 times the square root of 5 times the square root of 5 times the square root of 7. And the square root of 2 times the square root of 2 is 2. That's why that other part was super important. And the square root of 5 times the square root of 5 is 5. So we end up with 10 square roots of 7. Again, when we're talking about what you're going to write out, you do not have to write out this step. If after you've done this, you can go, okay, the square root of, in your head, the square root of 2 times the square root of 2 is 2 times the square root of 5, excuse me, times the square root of 5 is 5. That's 10. That gives me 10 square roots of 7. Great. Okay? And you can do that from here also. Square root of 2 times the square root of 2 is 2. Square root of 5 times the square root of 5 is 5. 2 times 5 is 10. And I have this square root of 7 that's left all by itself. Okay? So we still have a square root of 7. All right, so let's practice some of this. So if we're simplifying something like the square root of 45, the fastest way is to think of the biggest perfect square that'll divide evenly into that number. Yes.
9.
Yes. So the fastest way to do this is to at least think about, you don't have to even write it down, that the square root of 45 is the square root of 9 times the square root of 5, which is 3 square roots of 5. What?
I got it right.
Okay.
I did.
The other way that you can do this is by prime factors. So if we're dividing 45, 5 goes into that 9 times. 3 goes into 9 3 times. And 3 goes into 3 once. I'm done. The square root of 3 times the square root of 3 is 3. I have a square root of 5 still left, and you can do it that way. Either way, perfectly good. All right, the reason a lot of students don't do perfect square factorization is problems like this, where for most people, I imagine there's some of you that are good enough with working with numbers that can look at this and go, oh, I know a perfect square that'll divide evenly into that. But for most students, they can't look at that and say that. I can, but it's not a fair fight. I've been doing this for a long time. Is there anyone who sees the perfect square that'll divide evenly into this?
I don't see it right away. I didn't see it right away, but I did the problem and I know what it is, I think.
So what is it?
49.
Yeah. This is the square root of 49 times the square root of 3. So that's 7 square roots of 3. Again, that's not something that most people can do. It is a skill that you can learn, but most people can't look at that and do that. So what most people will do is divide this up. And it doesn't matter to me whether you're using factor trees or if you're doing what I usually call a factor tower. You do have to think of a prime number that divides evenly into this. Now remember, prime numbers are numbers that have exactly 2 factors, themselves and 1. So numbers like 2, 3, 5, 7, 11, 13, 17, those are all prime numbers. On this one, there are actually 2 different prime numbers that divide evenly into this. And it doesn't matter which one you see first. Before I go on, I would be remiss if I didn't teach you a really cool trick. Do you guys know the trick for figuring out if something's divisible by 3? Yeah.
Isn't it like it ends in a 9, 8, or 7?
No.
Like add the numbers, and then if it's divisible by 3.
Yes, if you add the digits together, 1 plus 4 is 5, 5 plus 7 is 12. Is 12 divisible by 3? Yes, then so is this. That works not only for 3, but it also works for 9. Okay, so when I do this one and I get 12, 9 doesn't divide evenly into 12, so this is not evenly divisible by 9. Now, we're looking for prime numbers, so 9's not so much of an advantage, but it is divisible by 3. However, when I look at that, I immediately go, yeah, that's divisible by 7. Because it's a 14 and a 7. So that's 21. I'll divide that by 7 again. And then divide that by 3. And we've got the square root of 7 times the square root of 7 is 7, and I have a square root of 3 still left. Oh, okay. I'm going to back up for just a second before we go on. Notice here the instructions say simplify each completely and, we didn't do any and give two consecutive integers that the radical lies between. In other words, what two whole numbers is the square root of 45 in between?
7 and 8 and 7.
No,
7 and 8?
not between 7 and 8.
The square root of what?
6 and
Square root of 45.
Oh,
6 and
45?
7?
Yeah,
It's between 6 and 7. How do you know that?
I thought you said
Because
49.
it's less than 49 and more than 36.
Yeah, so your thinking on that is the square root of 36 is less than the square root of 45, which is less than the square root of 49. So the square root of 45 is somewhere between 6 and 7. Thank you for not making me roll my eyes. And it's also helpful on this to know your perfect squares. So like the square root of 147.
12 and 13.
Yeah, because,
144 is 12 squared,
yep,
and 169 is 13 squared.
exactly right. So this is between 12 and 13. All right, let's go on. So without doing any dividing beforehand, does anyone see what
9.
is the largest perfect square?
Oh.
There's a bigger one. Pardon?
13?
Yeah, number 3. No, 13 doesn't go evenly into 180. And I don't want a prime number. I want
36?
36.
What?
Wait,
Now, let's say that you didn't see 36 first. Let's say that you saw 9 went into this evenly, because I think that's the easy thing to see. If you do it that way, it's not wrong, but you're going to have to do the process twice. This is the square root of 9 times the square root of 20, which is 3 square root of 20. What perfect square divides evenly into 20?
4.
4. So this is 3 times the square root of 4 times the square root of 5. So that's 6 square roots of 5. If you want this method to be fast, you really do have to think of the biggest perfect square that'll divide evenly into this, which is 36. And that's 6 square roots of 5. Heaps a lot faster. If you're doing it by a factor tower or a factor tree, you have lots of choices as to what to divide by first. You can divide by 2, you can divide by 3, you can divide by 5. A lot of times I divide by 2, although mostly I try to divide by the biggest number because it whittles it down faster to more manageable numbers. But I often start with 2 because I'm really good at dividing by 2, and other things I'm not always as good at. So 2 goes into 180 90 times. 2 goes into 90 45 times. Can't divide by 2 anymore. So I'll switch over to 3. Goes into 45 15 times. 3 goes into 15 5 times, and 5 goes into 5 once. So the square root of 2 times the square root of 2 is 2. The square root of 3 times the square root of 3 is 3. And I still have a square root of 5 left. And then what two numbers does this lie in between? Yeah, it's between 13 and 14. Because 13 is the square root of 169, which is less than 180, and 14 is the square root of 196.
We can just write 13 and 14.
Yes, ma'am. Absolutely. I just wanted to show why. All right, let's take a look at this last one in this section, the square root of 216.
Is it 36 again?
It is 36 again. How many times does 36 go into 216? 6 times. And that's 6 squared is 6. If you can see that, again, that's the fastest way to do that. And I mean, just a peek behind the glass here, I don't spend a lot of time talking to my on-level students about this because in the main, a lot of them have their number skills aren't good enough to do this. There are some who are, but there's a lot who are better off doing factor trees or factor towers. For you guys, I'm like, hey, I think you're all smart enough to be able to do this. Now, whether or not you're willing to put in the effort, that's another story.
I'm not smart enough to be able to do this.
Oh, yes, you are. Let's do it by factoring it. What do you want to divide by first?
36?
No, it has to be prime factors.
2.
All right, 2, that's 108. So once I divide by 2, I'm going to keep dividing by 2 until I can't do it anymore. That's 54. 2 into 54 is 27. Can't divide by 2 anymore, but I can divide by
3.
3.
Then it's 9. 3. 3.
And then 3.
So I've got square root of 2 times the square root of 2 is 2. The square root of 3 times the square root of 3 is 3. I have a square root of 2 left over
And the square root of 3.
and a square root of 3 left over.
So you times them together to get the square root of 6.
Yeah. We multiply the whole numbers together and we multiply the square roots together. All right. And then 216 is between what? 14 and 15? Because 14 is the square root of 196, which is a little less than 216, and 15 is the square root of 225, and 225 is a little bit more than 216. All right, let's talk about multiplying and simplifying. You will not have a lot like this first one, although you'll probably have a couple where they'll have 4 times the square root of 72. This is really just, I gotta simplify the square root of 72 and then multiply that answer times 4. So on this one, I think many of you will be able to see what's the largest square root that'll divide, largest perfect
36.
square. It's 36. I seem to be stuck on that today. So that's going to be 4 times 6 times the square root of 2 is 24 square roots of 2. You won't be doing that a lot. You will be doing it occasionally. What you will be doing a lot are problems like these next several. The first one and the second one are really simple. After that, it gets a little bit harder. But here, what we're going to do is kind of group these square roots of 2 together. Because what's the square root of 2 times the square root of 2?
2.
2. And 7 times 2 is 14. I'd say it doesn't get much easier than that, but the next one is actually even easier. 11 what?
11. No?
11 square roots of 15. We're multiplying, not adding.
Oh.
Wait, that's it?
Is there any perfect square number that'll divide evenly into 15?
Whoa, this is like,
Whoa, dude.
Sometimes math is easy. All right, let's do this one. If I multiply these two together, the square root of 15 times the square root of 3 is what? Square root of 45. Thank you. And now we need to simplify the square root of 45.
3. 9 and 5.
Yeah, it's the square root of 9 times the square root of 5, which is 3, times 12 is 36. Square roots of 5. What? You're acting like I performed a magic trick.
Yes, you did.
All right, let's do the same thing here. That'll be 19 square roots of 12. What's a perfect square that divides evenly into 12? 4. So that's going to be 19 times 2 times the square root of 3 is 38 square roots of 3. Now, when you're actually doing these problems, this is a skill that you need for the unit, but I'm not specifically testing this. So how much work you show on this is entirely up to you. If you can go from the beginning all the way to the end in your head, fine. Have at it. Okay? All right, well, that's multiplying. Now let's talk about dividing. And this will be our last thing for today before we take our quiz. So when you're dividing, there's a rule, and it's become less of a rule in the last several years, but it still kind of is a rule, is that simplified expressions for these cannot end up with the square root in the denominator. You never want to end with the square root in the denominator. So let me show you on this one. I always first rewrite these as a fraction. In this particular case, this is a really easy one, because what's the square root of 2 divided by the square root of 2? 1. And what's 17 times 1? 17. All right, how about this one?
84 square root of 5.
Yeah. Three goes into 15 5 times, so we've got 84 times the square root of 5. Those are the simplest type. Now for one that's not quite as simple. Actually, several. What if I have 16 divided by the square root of 2?
I don't know, man.
2 square root 16s?
No. What did you say, Molly?
I didn't say anything.
Oh, I thought you said something also.
Would you multiply?
By what?
Square root of 2? 1.
We're, between the both of you, we're right. We're going to multiply 1 in the form of
A square root?
the square root of 2 over the square root of 2.
What did it was?
I'm going insane, don't mind me.
Okay. So 16 times the square root of 2, well, there's nothing I can do with that. But the square root of 2 times the square root of 2 is?
1.
No.
2.
2. Listen to Kyle. He's been saying it all period. The square root of 2 times the square root, yes, every time I've said it, something about the square root of 3 times the square root of 3 is, and you immediately have it.
I do.
trying to give you a compliment, and
Oh,
yet,
thank you.
and then I can divide the 2 into the 16 because they are both whole numbers. 2 into 16 is 8, so this is 8 square roots of 2. You're going to do problems like this so often that many of you will get to the place where you don't write any of this down and you just go straight to 8 square roots of 2. All right, let's look at this one. 23 divided by the square root of 3. Oh, by the way, I didn't write out this is called rationalizing. The denominator. The square root of 2 is part of a class of numbers called irrational numbers. And you're like, wait a minute, irrational, doesn't that mean it doesn't make sense? Again, back to the previous topic, people didn't think that there were numbers like this for a long time.
They're just imaginary.
No, imaginary numbers are a different kind of numbers.
Imaginary, isn't an imaginary number like I?
Yes.
Oh yeah.
And do you know what I stands for?
It's like the square root of -1.
It's the square root of -1.
Yeah.
Wait, I is a number.
I is an imaginary.
Yeah, I is the unit imaginary number.
Wait,
It's
so
a
is it
square-
kinda like Google and Infinity?
Pardon? No.
No?
It's the square root of -1. It's not a real number, it's an imaginary number. All right, back to this. So we've got 23 over the square root of 3. So what should we do to rationalize the denominator?
Multiply by square root of 3?
Yeah, multiply by the square root of 3 over the square root of 3. That's 23 square roots of 3 over 3. And will 3 divide evenly into 23?
No.
No. So we'll just leave it.
Oh.
Oh.
That's nice. All right, let's try this one. So we've got 42 square roots of 2 over the square root of 3. To rationalize this, we'll multiply by
Square root of 3. Square root of 2 and 3.
Square root of
5,
3
6.
over square root of 2.
no, because that wouldn't be multiplying by 1 then.
Square root of 1.
2 over the square root of 3.
That,
Square root of
that's not 1.
Square root of 1?
6.
Square root of 1?
No.
Square root of 6?
Square root
Okay, stop guessing, please.
Square root of 6 over square root of 6.
That's an interesting idea, but that would give us other problems, and I'll show you in just a second. We're just going to multiply by the square root of 3 over the square root of 3. Whatever that square root in the denominator you want to get rid of, that's what we multiply by in the numerator and in the denominator. So that's 42 square roots of 6 over 3.
Yes.
And then is 42 divisible by 3?
Yes.
Yes. Goes in 14 times. So it's 14 square roots of 6. So
So good. I totally understand.
don't worry about writing this one down, but just watch for just a second. It's a good question. Why don't we multiply by the square root of 6 over the square root of 6? It gives us 42 square roots of 12 over the square root of 18. And then the square root of 18 simplifies to 3 square roots of 2. Well, now I've got a square root on the bottom again. All right, which is what I was trying to get rid of.
Ooh.
Okay, so that's why we just multiply by the square root of 3 over the square root of 3. Okay,
Yes.
all right.